So what we learned so far? We start talking about statistics as a branch of math, and we know that it contains some steps. The very first step is to ask a question. Step one, ask a question. In step two, we are interested in collecting data based on the question that is asked. Collect data. Then after collecting those values, either numerical or categorical, we're interested in visualizing the data that we have. So step three, give us a way to visualize the data. Well, as I mentioned before, when we're talking about visualizing the data, if they have numerical data, one of the easiest way to visualize them is to use histogram, numerical data. We use histogram. And if we have categorical data, like hair color, eye color, blood type, we're going to use bar graph. Categorical data, bar graph. Of course, we have other graphs, but we're going to focus on these two in our class. Also, we're going to talk about dot plot. After visualizing the data, we're interested in associating numerical characteristics to our data. So in step 4, we want to know what are the measure of center? What are the measure of variability? Numerical characteristic or analyzing the data. Let's try to analyze the data. By finding a measure of center. Measure of center. We talked about measure of center before, finding the average, mean, or mode, or median. Well, measure of variability is the topic that we're going to talk about today. Measure of variability. And remember, after step 4, they have step 5, making inferences, making conclusion. So our focus today is on measure of variability. As we divided up the measure of center into some characteristics like mean, average, mode, and median, we can divide up the measure of variability into different classifications. So when it comes to measure of variability, you're dealing with range, standard deviation, and also we can talk about 5-number summary interquartile range. 5-number summary and interquartile range. So these are the focus of our today's topic. Let us take a look at our notes. We have a table about monthly temperatures for San Luis and San Francisco. We have typical monthly temperatures of 2 cities in January in February, in March, April, May, June, July, August, and it stops at December. Well, first of all, you have a collection of data, but you're trying to see if the variability in the first one is different from the variability in the second sample. So when we try to compare samples, first we try to find the typical value, measure of center, and then we move on to find variability. You might have two samples with the same typical value or center, but variability in those two samples are different from each other. So when it comes to variability or spread in our data, one method to visualize the data is to use dot plots. Let us take a look at San Luis first. San Luis has 29.9, 33.9, 45.1, 56.7, 66.1, 75.4, 79.8, 77.6, 70.2, 58.4, 46.2, and 33.9. These are the collection of temperatures that we collected for San Luis. Well, how do we visualize the data? One easy way to visualize the data here is to use dot plot. You have a horizontal line with 25 as the starting value. Why is that? Because the smallest value in the temperature in San Luis is 29.9. So let us start by scaling this horizontal line at 25. 25 to 30, 35, 40, 45, 50, 55, 60, 65, 70, and we're going to stop at 85. Why is that? The maximum temperature that we have here is 79.8. So we're going to stop at 85. Take a little bit of space between 80 and 85. Well, as I mentioned, the smallest value, the smallest temperature in San Luis is 29.9. So we're going to put a dot on top of 29.9. Then we have 33.9, which is repeated twice. 33.9 repeated twice. So when it comes to 33.9, we're going to put two dots on top of 33.9. The next value is 45.1. So we're going to put a dot on top of 45.1. Well, the next value, the next temperature is 46.2. Okay, I'm going to put a dot on top of 46.2, and we're going to continue this process. As you can see, the spread starts from this point here, and it stops at the maximum temperature, which is 79.8, the last dot here representing that maximum value. Okay, this is for San Luis. Let us take a look at San Francisco dot plot as well. It helps us to visualize the data better and compare them. These are the temperatures for San Francisco. Okay, as you can see, these numbers are very close to each other, 50s and 60s. So take a look at the smallest value here, 51.1, 51.1. And then you have 51.7. So as you can see, these numbers are very close to each other. The starting point and the ending point, there is less spread in the data in San Francisco. You see more spread in the temperature in San Luis. We have two data sets. By looking at the dot plot, we can compare the spread of these two data. Well, let us take a look at the board. Our focus is on measure of variability. We have a nice example, San Luis and San Francisco temperatures. We're going to do some calculations. Well, so when it comes to measure of variability, measure of spread, we either deal with the very smallest and very largest value in our collection. We find the difference between them and we call it the range of the data. So the very first one is called range. How do we define range? Range is defined as the difference between the maximum value and the minimum value in your collection. Well, for example, in San Luis, the information that we have are the minimum value and the maximum value. Suppose I want to find the range in San Luis. What is the maximum value in the temperatures that we have? It seems like it is 79.8. This is the maximum temperature. And the minimum temperature is 29.9. 29.9. So what's the range of temperatures in San Luis? What about San Francisco? When we talk about San Francisco, we're interested in finding the range, which is, okay, the maximum value in San Francisco is equal to 62.3. And the minimum value is 51.1. So the range in San Luis is 49.9, and the range in San Francisco is going to be 11.1 degrees. So as you can see, the range in San Luis is higher than the range in San Francisco, and we say that San Luis temperatures has more variability or more spread. So we say that since the range of San Luis is larger than the range of San Francisco, we have more spread or variability in San Luis. Okay, very well. So I expect you to ask, in range, you only took 2 values out of all of these data. What about the rest of the numbers? How do we use the rest of the numbers? Well, in this case, we're going to find something that we call the standard deviation. Standard deviation. Well, standard deviation gives you a measure that this number, this value, gives you the spread, the variability from the mean and average. How do we calculate this standard deviation? To calculate the standard deviation, we're going to use our calculator. So our goal is to find the standard deviation for these two data sets. This is our goal, to find standard deviation. We just write it as SD, standard deviation. First of all, make sure if your calculator needs to be resetted, you reset your calculator. So remember that to reset your calculator, turn on your calculator, second, plus, we need to reset, go to reset and reset two things in our calculator. The very first one is all RAM, reset the whole thing, then repeat this process, second, plus, find reset, and reset the defaults. Okay, let us start. First, we want to enter the data. Let us enter the data for San Luis first. So we're going to click on Stat. Stat. Go to Edit. And we're going to enter information about San Luis in L1, in the very first column, L1. So let us use L1. So what are the numbers in L1? What values do we have? We have 29.9, enter. 33.9, enter. We have 45.1, enter. 56.7, enter. 66.1, enter. 75.1, enter. $79.8. I made a mistake here. It's 75.4. Let us fix that. 75.4. Much better. 79.8. Well, we have 77.6. Enter. And 70.2. then we have 58.4, 46.2, 33.9. Okay, these are the information that we have for San Luis. We entered all in L1. Okay. Now, to find the standard deviation, to find SD, click on Stat. After clicking on Stat, we need to select Calc. Remember that we did the same thing when we were finding the measure of center for our collection. So Stat, now go to Calc. And you're going to select one variable statistics. One variable stats. Okay. Everything in order. We know our list is L1 because we want to calculate San Luis measure of variability. So we're going to go to calculate, and here we go. It gives us the mean. Don't need the mean. Remember that we want to find standard deviation. We're looking for the measure of variability here. So what is that measure of variability? Since we have a sample in calculator, it denoted it by S sub X. S sub X is the standard deviation of our sample. Okay, well, so S sub X, or standard deviation of our sample, is equal to 18.07. 18.07, what's the unit? Degrees. So let us go to the board, enter. After entering all of this information, our calculator will write down the summary on the board to make sure we have all of them written up there. 18.7. So standard deviation of San Luis is 18.07 degrees. So what's the difference between the range and standard deviation? The range just took into account the maximum value and the minimum value. And as you can see, 49.9 just shows how far away the maximum and minimum value are in your sample. Standard deviation, we entered all of our information in a calculator and it gives us this number. It says on average, the difference between a random value in your collection from the mean is 18.07 degrees. Okay, now let us find the standard deviation for San Francisco. Let us get back to our calculator. We have to repeat all of this process for San Francisco. So what are we going to do? Enter the data for San Francisco. We go to Stat. So go to Stat, go to Edit. At the same time, I want to keep information about San Luis in the first column. So I'm going to move to the second column to enter the information about San Francisco. So let us use L2. So let us go to L2, the information that they have. Well, okay, 51.1, enter, 54.4, enter, 54.9, enter, 56, enter, well, 56.6, enter, then 58.4, okay, 59.1, 60.1, 62.3, 62, 57.2, and 51.7. Okay, we entered the information L2. Now we need to find SD, standard deviation for San Francisco. So to find SD, repeat the same process, stat, calc, go to stat, go to calc. Again, we need to use one variable statistics, one variable stats. Okay. But note that your list is L1. Remember, San Francisco information are entered in L2. So we need to change L1 to L2. Change L1 to L2. So you're going to click on second 2. Second 2. Okay. Let us do the calculation. Well, it calculates the mean and the standard deviation, as you can see, S sub x is 3.62. S of x is 3.62 degrees. Standard deviation of San Luis is 18.07, and the standard deviation of San Francisco is 3.62 degrees. So standard deviation of San Francisco is 3.62 degrees. As you can see, again, since the standard deviation of San Luis is larger than the standard deviation of San Francisco, it means that San Luis temperatures, they have greater variability, greater spread than San Francisco temperatures. Very well. So other than range and standard deviation, what we can find 5 numbers summary. We can find the quartiles that divide up the data in 25%, 25%, third part 20%, and the last part 25%. So other than finding standard deviation, we can also find 5 number summary. Five number summary gives you quartiles. Well, when you have a collection of data, remember that the definition of median was the middle number. Median is called the second quartile. So median or middle number is called the second quartile, Q sub 2, or the second quartile. What's the meaning of that? It means that 50% of your data are on the left-hand side of the median, and 50 other percent of your data are on the right-hand side of your median. The beginning number is the minimum value. The maximum is the largest value in your collection. Well, you might say, hey, now that we have two sets of data, why not finding the median on the left and the median on the right and call them first quartile and the third quartile? So what are we doing? We are taking the first set of data. We find the median of the first set of the data, and we call it the first quartile, Q sub 1, or the first quartile. We're going to do the same thing for the second half of the data. So now that we have the second half of our data, we're going to find the middle number, the median of the second half, and we're going to call it the third quartile, Q sub 3, third quartile. So what is 5-number summary? The 5-number summary includes the minimum, Q1, maximum, at the end, let's write this here, maximum, Q sub 2, and Q sub 3. 5-number summary includes minimum, maximum, and all of the quartiles that you have. It's very popular to find the difference between the third quartile and the first quartile, and they call it interquartile range. I, Q, R, Q3 minus Q1. Interquartile range. So this is our goal, to find 5-number summary. So we're going to find these 5-number summary values for both San Luis and San Francisco. For San Luis. So what are we going to do? We're going to turn on the calculator and hit stat. As usual, we have to enter information in one of the columns that we have. So enter the data. So stat, edit. Note that I already entered the information about San Luis in L1, so I don't have to re-enter these numbers. Enter data in L1 for San Luis. After that, we're going to hit on stat We're going to go to calc as usual. Then one variable stats. Okay. Just make sure that you're using L1 for San Luis. So you're going to hit second, 1 second, 1 to get to L1. Second, 1 for L1. Well, okay, so let us go to calculate. What do I have so far? I have the mean, I have the standard deviation, I have n equals to 12. It means that I have 12 degrees, 12 temperatures for San Luis. So now to get more information, to see more information, let's go to the next page. Okay, here we go. We have our minimum, 29.9. So the mean is 29.9. Q1, the first quartile, is 39.5. Median or second quartile is equal to 57.55. Well, Q3 for the third quartile is 72.8. And finally, the maximum value is 79.8. These are your 5-number summary. For San Luis. Well, so now I expect you to ask, how do I visualize these data? You gave me minimum, maximum, the first quartile, the second quartile, the third quartile. The next question that you should be asking is how to visualize this. So we're going to go to second, y equals to, so to visualize the 5-number summary. We're going to click on second, y equals to. So second, y equals to. You're going to use the plot in number 1. Plot in number 1. Okay, enter. Turn it on. Turn on the plot. Then go to the next category. The next category gives you, well, you have different types of graphs here. You have your histogram, you have your box plot. Box plot actually helps you to visualize 5-number summary. So what you're going to select, you can either select the box plot here, or you can select the box plot here. So select a box plot. A box plot is like this. So let us select the first one. It also shows where the outliers located. So I'm going to select that. And since all of the information are in L1, remember that San Luis information are in L1. Now just hit graph, and then zoom along with 9. Zoom 9. Zoom 9. As you can see, you have your box plot showing the distribution of your data for San Luis. This is your minimum value. This is your first quartile. All of these numbers are on the horizontal axis, the minimum value, the first quartile, the second quartile, and the third quartile, and finally, the maximum value is located here. 25% of your data, 25% of your data. We can check to see what values do we have here. We can go a little bit further up. Take a look at these values. So as you can see, the median that we found was 57.55, which is very close to 57, located on x-axis. We can go to the next one. We can find Q3, 72.8, very close to 72 here. So now let us find the box plot for San Francisco. Leave this right here so you can compare the information. Okay. Now for San Francisco. First, we have to enter the data, follow the information, but we're going to put everything in L2. Okay, stat, edit, L2. We already entered all of the information about San Francisco in L2. Now, go to stat, go to calc, the same process. One variable. Now we have to change this to L2. Just make sure we want to use L2. So second 2. Second 2. It changed the column to the second column, L2. Let us do the calculation. Okay, we need to go to the next page. Minimum is 51.1. Q1 is 54.65. Then the median, or Q2, the second quartile, and the median is 56.9. Q3, the third quartile, is 59.6. And the maximum value for San Francisco is 62.3. These are the information that we found for 5-number summary. Now we want to visualize this. To visualize the whole thing, click on second, y equals 2. You can select the second plot. That's fine. Let us select the second plot Enter. Turn on your plots. And now between these graphs that you have, you have to select either of these two box plots. Let's select this box plot. It doesn't matter. We selected this box plot, and now it must be L2. So second, 2. Now graph. You can click on zoom line, or you can just leave it as it is. It's already visible to you. So you have the plot for San Luis and you have the plot for San Francisco. As you can see, the spread for San Luis is very high, but the spread for San Francisco is very small. The data are all squeezed around the center for San Francisco.